Welcome back, everybody. This is our next visual elements lecture on the concept of the illusion of three-dimensional space. So some things that we want to be thinking about analyzing artwork is that, again, art is artificial, but most of it is representational. Most of it does show imagery that's meant to remind us of or suggest things in the real world. So how do we make something feel real to your eye if it is unreal, if it is something completely flat? How do we trick your eye into seeing something that seems to be three-dimensional? That's our issue today. So one of the first things that I like to talk about when we start thinking about space is a concept of what we call visual weight. So in the screen right now, you see two circles. One is placed really high in the picture plane. What we call the picture plane is boundary, the surface that an image, a drawing, or a painting takes up. Could be called the plane, the surface of the drawing or painting, by the picture frame that edges around the rectangle. And you see one of those circles is near the top of the picture plane, but another is near the bottom. Now, experience the effect of gravity in our lives. We're aware of up and down because of the effect of gravity. That very much is what's being implied by the placement of those circles. Even though they're the same shape, same color, and they're not meant to really be anything, I could easily to think about one as being a balloon and one as being a bowling ball, because you've experienced weight and gravity your whole life. Things lower in the picture plane with being down near our feet, because we spend most of our lives as upright beings. Down for us is close to the ground, right? And that's what is an idea that we use visual weight to imply in our painting and drawing. So we can build on those concepts and create illusions with really simple techniques. So for instance, in this first pair, in this red box at the top left, I have two circles. Both of them are low in the picture plane. But if I ask you which one would you think is heavier, I bet you'd vote for the one on the left, simply because it is larger. So generally speaking, larger shapes read as being heavier than small shapes. Two shapes the same exact size, one that is darker in color or value is going to feel heavier than the same exact size thing that's lighter. So the darker or textured one are exactly the same size as the ones to their right, but the dark one and the textured one feel heavier than this. We've already talked about the placement issue, so two shapes the same size, if one is floating up near the top and one is sunk to the bottom, this one will feel heavier. In these examples here, against this bluish background, I have two small things that feel about the same weight as this one large thing. So this larger shape can balance a couple, three smaller ones. We can create balance by using a small thing that's darker or textured to balance a larger thing that is lighter. So a lot of what we're looking at here when we're talking about visual weight and balance will have a lot of importance when we think about issues. We can think about those issues in terms of balance if we think about a teeter-totter or the traditional scales where you have two plates on either side that are coming into balance. I can balance my large shape with two smaller shapes of the same value or same color or same texture. I can balance a large plane shape that's darker and textured. So I can create balance without having to use absolute symmetry. Absolute symmetry can get a little boring after a while. Placement in the picture plane can also be added to that simple idea. We can create even more convincing sense of spatial illusion by simple use of a horizon line and some color. By throwing in a horizontal line there, a little lightish blue and some greenish, I immediately make this feel like the ground versus the sky, which makes this rectangle feel much closer than this one, even though they are the exact same size. So I can use these ideas of space and visual and placement to create pretty sophisticated illusions of depth, even if I'm not very good at drawing. I could do this with collage. For here, it seems that you have 3 circles overlapping one another. So obviously this one seems to be in front of that one. That's a pretty easy concept, obviously. What if I increase that illusion of space by making the objects now get smaller? Now I have overlapping, but also the shapes are getting smaller as they seem to go back in space. So if I combine all of those ideas with this concept of placement, that this is closer to me because it's that feels further away because it's higher. If I combine that idea with the idea of overlapping and diminishing size, check this out. I can make this thing feel really close to me because it's low in the picture, but it's also huge compared to the thing it overlaps and compared to the next thing behind it. So by combining overlapping, diminishing size, and placement in the picture plane, I can create a illusion of 3 dimensions, even just with some simple cutout shapes. I can get much more complex with my illusion of depth if I start using what we call perspective, linear perspective. This was a visual effect that people were aware of but didn't figure out how to make it a systematic, mathematical, geometrical system until about 1400. Somewhere around 1400, people began to do some really careful observations using grids and rulers that led to the discovery of a system underlying the illusion of 3-dimensional space. Essentially, for us, we want to remember that the eye level is the horizon. The furthest distance that you see at your eye level is the horizon. You can play with this the next time you're at the beach. If you are down on a towel, you will see a small-ish amount of water and a lot of sky if you're looking out at the horizon. Let's imagine looking at the horizon. You're seeing some water, but a lot of sky. If you stand up on your towel, though, you're going to see much more of the water because your eye level will now be higher. Your horizon line will seem to be at a higher point. The horizon equates to eye level. Your relationship to objects with straight edges also will play into how perspective works, where you are in with how your eye perceives those things in space. So if I'm facing straight ahead at some boxes, I am parallel to the plane of the face of each of those boxes. Then the sides of those boxes will appear to all recede away from my eye toward the same point at the horizon at my eye level. Where those lines meet is what we call the vanishing point. So anything that's parallel to me is going to have the same single vanishing point. And the line leading back to that vanishing point we sometimes call guidelines or perspective lines, leading lines, but they have a name, orthogonal. And we'll take a look at that spelling right there. This is your perspective line, leading line, guideline. That's the spelling of the word orthogonal. So in this case, I have a horizontal line representing my horizon, my eye level. I am parallel to this rectangle. I try to draw it in space by drawing in the orthogonals. From the top left and bottom left corner of that rectangle, I'm going to draw guidelines back to my vanishing point. If you imagine this as a building, it's as if I'm looking at a fairly tall building. Its height of is above my eye level, but it's resting on the ground. But if this is directly in front of me, that the building is a little bit off to my right. Because the front of the building is parallel to me, I should be able to see it, but I should also be able to see its left-hand wall. To draw that in, I'm going to draw in a horizontal line, or vertical line rather, where the wall ends. The building I just drew on the left is to my left. That dot of the vanishing point is directly ahead of me, so this is to my left, but it is entirely below my eye level, so I will not only see its wall, but also the ceiling, or the roof rather, of this building. So I drew in left, the top right, and the bottom right corners, and then drew where those edges of the roof and the wall stop. I'm going to add the animation so you can see it again. 1, 2, 3 orthogonals. Show where the walls, roof end, and boom, I've got a believable three-dimensional space. The way that the doors and windows are done on one point, start with the details on the facing plane, mark the height of those things, and then draw in orthogonals leading back to my vanishing point. This avoids a very common problem. A lot of times when people are doing the doors and windows on the side of a, they'll just make all of the lines parallel to the angle of the top, which is okay at the beginning, but if I kept doing that, boy, would that make my doors, because they would be going down into the ground. So the orthogonals are kind of like the spokes on a bicycle wheel. They all go to the vanishing point. So as we get closer to the horizon line, they're going to get more horizontal. As we get below the horizon line, those are going to angle up. So one-point buildings, objects of any kind that are straight-edged, can be perspective if we're aware of where that vanishing point is. We refer to this type of arrangement as two-point perspective, much more common. It's kind of rare for us to walk through a city keeping ourselves perfectly parallel of the buildings we're looking at. It's much more common for us to see things at a slight angle. And so that brings us to the idea of the two-point perspective. In this case, we're not facing head-on to either side of these buildings. We're actually facing the corner, and each of the two walls seems to be away from our eyes to the left and to the right. I also really like this diagram because if we imagine this as the paper or the edge of our painting canvas, or the edge of our camera viewfinder, the edge of the photograph, then you can see the vanishing points could actually be outside of the picture area, and that absolutely can happen. But what's happening here is that we are still aware that the horizon is our eye level, and if we look, for example, at this building that's kind of floating up in space, look at the roof line. Even though we know the building is meant to be perceived as having a flat roof, that angle looks really sharp. This angle looks a little bit less sharp, more of a shallow angle. And that indicates to you, if you see a shallow angle, it means the vanishing point is really pretty far away. If you see a sharp angle, it means the vanishing point is pretty close. So again, if we think of this as just a simple diagram, the horizon line is your eye level, the corner of the building is what's closer to you, so to recede away from you to the left and to the right toward two different vanishing points. Those vanishing points have to be on the same horizon, and the horizon, again, is your eye level. So to draw this, first step would be to show the height of the corner, and then do two orthogonals to the left, to the right. There's your building. The one that just appeared is a building that's entirely below my eye level. So I'll see not only the two walls, but also the roof. So the first step with that one is still to draw the corner, orthogonals to the vanishing point, then decide where the two walls end, and then I'm going to connect top back corner on the left-hand wall to the right-hand vanishing point. The top back right corner I'm going to connect to the left vanishing point. And that's going to create my roof line. It'll fill in that spot. So let's let the animation do its thing again. Start with the corner for orthogonal, show where the walls end, and then crisscross from the left back corner to the right vanishing point, from the right back corner to the left. Gives us our missing corner. To do the doors and windows on these is really easy. All I do is mark off the height of units on the corner and then line those lines up with my vanishing points. Again, as we get closer to the horizon, those lines get more horizontal. As we dip below, they get more of a sharper angle. And again, we can have buildings that have complex shapes. We can have things that extend out over space. We can have things that recede inside of those spaces. But as long as we know what position we're in, if we're looking flat at the front of a building, we're in a 1-point position. If we're looking at the corner, we're looking at a 2-point illusion. Now, in this case, you can see that this painter from the early Renaissance in Italy has not quite figured out how perspective works. The white lines were added. I took a photograph of this image from a design book where they had added those white lines. But basically what the author was doing was taking the edges, the orthogonals, and trying to see if they met at a common point. And obviously they don't. Artists were aware of this illusion but hadn't figured it out. So how did we get there? Well, people actually ended up making grids of wire in frames, putting those frames in front of the thing they were trying to draw, and then drawing what they saw on gridded paper. And that allowed us to create these incredibly accurate renderings of what the world looked like. And it led people to discover the edges of these walls were moving toward the same point in space. It's kind of a remarkable discovery. You can see that here. We've got this pretty well perfect now. The last image was from the early 1300s. Here we're in the early 1400s. And the painting is on the wall of a church. If you stand in front of it, though, it looks like you're looking down a hallway with a curved ceiling. Well, a barrel vaulted roof. And what it seems to be is that the hallway is pretty long and it goes deep in space behind you here. So away from you, rather. That line that you see here is actually pretty much where average people's eye level, people of average height, if you took all of the people in our class and averaged out how high our eyes are from the ground, we'd be somewhere in the neighborhood of this line. And it really does appear that from that point, those lines in between the details in the roof, or ceiling rather, all meet at the same point. Illusion of space. It was achieved through devices like this, a simple frame with a grid on it. You would look through it at whatever you were trying to draw and then draw that on a paper that had the same grid. And you can see that here in this image by the artist Dürer. Is a device that's allowing him to keep his face or his head in the same position so he sees everything from the same point of view. He's now going to be able to apply the rules of perspective to something that doesn't have straight lines and edges, the curves of the human body or the curves of this musical instrument. And that's going to allow us to create even more believable illusions of space. I took these photographs in our classroom building back when we used to go to classroom buildings. And you is to take my phone and just take a snapshot of the hallway, holding the phone up pretty high so that my eye level or the level of the phone is pretty near the top of the door of the classroom. Here it's at normal eye level. I took it right next to my own face. And here I got down on the floor and took of the same space from a low vantage point. And you can see if I put lines where the wall meets the ceiling in each or photographs rather, you can see that the lines meet at different points relative to the window at the end of the hallway. That shows you where my eye level is. See how it's getting lower? That eye level changes what you see. If I'm lying on my stomach on the floor of the hallway, then the angle of the lines of the doorways looks like it's a downward angle. If I've got my eyes at the height of the top of the doors, then it looks like the doors all line up in a straight line straight across. So that shows you how we can apply the idea of perspective in our daily lives. You can see from looking at this photograph, I bet you can immediately tell me whether you're looking at a 1-point or 2-point situation. If you're facing the building head on, 1 point. In this case, you're facing the corner. That makes this a 2-point illusion. So if I were to draw it and just kind of freehand things, does this look like that building? Not exactly. It's not exactly right. And you can tell that I don't have the top angles correct, and I don't have the length of the walls correct. What I've done here is I've just taken a piece of rectangle, drawn a horizontal line on it to be my horizon line, popped in a couple vanishing points kind of randomly, and then dropped corner, connected the corners, finished the walls to create a believable two-dimensional object or 2-point perspective object. That's great, but it doesn't really look like this. Look how weird it is if I put the photograph under the drawing. You see how wrong it is? I've put my horizon line way too high, and I've made the length of the walls wrong, one too wide and one too short, and I've made completely random places. So if I want real accuracy, I could take that original photograph, I can take any two parallel lines, top and bottom of a pair of windows, on one side, and two different ones on the other. Take a ruler, just find where those two meet, and that shows me where the vanishing points are. I could use the top and bottom of those. I could have used the top of the building to do this. But once I've found those 2 points, I can then go in and find out where my horizon line is. And of course that makes perfect sense, doesn't it? If I'm taking a photograph of this building from across the street and it's 7 or 8 stories tall, the building is going to be way above my eye level. My eye level is going to be much closer to the ground, and that's exactly what this proves. Once I have that information, where the corner of my building is, where the horizon line is, I can measure from where the corner crosses the horizon to the left-hand vanishing point, and where the corner crosses the horizon to the right-hand vanishing point. I can measure the height of the building in the photograph, and that tells me everything I need to know to reproduce that photograph exactly. Using those measurements at a horizon line, placed my vanishing points and my corner based on those measurements, drew in the corner of the building, drew in my guidelines, and check it out. It's exactly the correct perspective of my original photograph. So just knowing the basics of 1-point and 2-point perspective would actually allow you, with some practice, to start drawing things in a really believable way. The basics, I'm not going to make you draw in perspective, so don't panic. The basic things I need you to know, though, for the purposes, is the basic rules of perspective, things people understood and then systematized. Rule 1, objects appear to diminish in size with increased distance. Fancy pants language to say stuff that's far away from you looks small. Rule 2, parallel lines appear to converge, and we call the vanishing point. Think of that as the railroad rule, the size of the rails of a train track seem to meet. If you're standing on a train trestle and you're looking across a flat piece of land, way out into the distance, it'll look like the rails of the train track are getting closer and closer together till they meet. Your rules for atmospheric perspective, or what we call landscape perspective. Objects higher in the picture plane are going to appear to be further away, and of course, objects further away are going to value less intense, more gray in color, less bright, and obviously less detailed than things that are in the foreground. These photographs show you the effect of making things lighter in value, less intense in color, grayer in color, less deep, smaller, higher in the picture plane is not just something that artists made up in painting and drawing. You can see it in photographs of the real world. So if I apply those ideas to geometric things or to computer rendered ideas, you can see how much I can create that effect of atmospheric perspective to create the illusion of 3 dimensions in space. This diagram to the right is one of my favorites. It's a photograph, quite a nice landscape photograph, that really shows you by highlighting where you see these darker values is in the foreground. The lighter values are almost all in the midground, and the palest values are far. It's a really good illustration for showing how to create this illusion of things being farther away. I can do it by simply making things smaller as they go away from me, but if I make them smaller and lighter and grayer and duller, it makes the illusion stronger. Even this diagram of a Greek temple is a pretty convincing illusion because the things in the background seem to almost fade into. So can we get more sophisticated with our illusions? Of course. This oil painting takes all of the things we just looked at and makes a really 3-dimensional illusion of space. This is the work of a great American landscape painter, Albert Bierstadt. He obviously knew how to create a depth on a flat canvas with oil paint. Last big concept for us for today is foreshortening. Pretty simple one. The thing that's in the foreground is going to seem larger, and the length of what is coming towards you is going to seem shorter than it normally. I often ask my drawing students to try to draw not the whole image that you're seeing here. We'll try to draw just his hand, and it's but a lot of times people will end up drawing a very long finger pointing at a weird downward angle. That's not what you're actually seeing here. Of course, what you're seeing is the tip of the finger and very little of the length of that finger coming. Effect of foreshortening. What's in the foreground is larger than normal. The length is dramatically shortened. Foreshortening. You can clearly see that is a hallmark of what we do in comic books illustration, and it is heightened, obviously, in this drawing. It's a little bit hyped up, but ultimately it would be the same effect if you saw it in photographed form. The actor's hand is bigger than the one that's far away in the distance, but the length of his arm is really short. So it's not something that artists just made up. In fact, you can absolutely observe in the real world every day. There's a bunch of examples that the textbook gives you that definitely are to play with. These are artists who are taking perspective rules and playing with them in ways that make these images like they have tricked your eye in a way to see something that is impossible. I love this part in the background. This obviously looks like the is overlapped by this building, and yet this woman is reaching out of the window to hand something to the man right there. She's lighting his pipe with a candle. There's all kinds of things that are happening that are physically impossible because the perspective has been tweaked. And you knew this one before you signed up. Great examples. M.C. Escher's print, Relativity, shows you something that feels absolutely perfect in its perspective, but is mind-boggling when you see this figure walking down the staircase and then see another figure walking down the underneath side of those same stairs. figure walks up this staircase, no round plane is absolutely correct. If you know your fantasy film, then you probably are familiar with the great 80s movie Labyrinth with the late great David Bowie in it as the Goblin King, and that obviously is modeled off of this example. Escher did a bunch of these inverted, impossible perspectives, and they're just a lot of fun to look at. This one really will mess with you. The longer that you look at it, the more it seems like it's drawn perfect perspective and yet is impossible. There's no way that this ladder can be both inside of it and outside of it at the same time. It's a pretty remarkable accomplishment. The ascending descending is my personal, because it seems totally rational and yet it is completely impossible. This seems like a downward descent down a that continues to go down, it continues to go down until we're right back where we started again. It's completely impossible, but really cool to look at. Same thing here with this waterfall. The water seems to be flowing into the foreground, downward, into this pool, that then somehow is going upward to fall again. It's impossible, but amazing. There are a lot of tricks that perspective can do intentionally, and you may be familiar with, is anamorphosis. The idea of an anamorphic image is one in which it appears to be in its proper in terms of perspective and scale if it's seen from a weird angle. So this example at the left is actually from Da Vinci's notebooks. He knew about this illusion, and people in the Renaissance were pretty well aware of it. The idea is that you could take an image like this coat of arms, create a distorted grid where the further you get away from the viewer, the grid is going to increase in length and in height. The closer you are to the viewer, the shorter it is in height and the shorter it is in width, so that if you view it from the right angle, in its proper perspective. That is at the heart of this illusion. There is an anamorphic image here that at first glance look like maybe it's a rug on the floor, but in fact, if you see it from this angle across the surface, the painting originally was hung. If you saw it from the correct angle, you would see that suddenly in perspective. This weirdly stretched out oval shape, actually, if you see it from the proper angle, creates the illusion of a floating three-dimensional skull. How cool is that? I really have seen this with artists working in chalk art. It's one of the best examples I can give you of tricking your eye with anamorphic projection. Very prominent in street work with chalk. If you see this from the side, you can see how crazy far away, huge her feet are relative to how small the floor art or street art is at the front. But if you photograph it from the right angle, it looks to this pool with her and that her leg is sticking straight up in space. I just gave you a bunch more examples just because they're incredibly cool. There are definitely artists who have used this trick for a long time, and there's sort of a reverse anamorphic that you can create with reflective surfaces. So if you create the distorted image and then have the proper shaped mirror to be placed inside of it, it's in perspective for you. That's being done even by some artists in fully 3 dimensions. Can you believe it? This is a sculpture that made that looks like some kind of really scary, distorted human mutated hand, that if you see it with this curved, or puts the image into absolute perfection, you would think you were looking at a real human hand. Pretty amazing. Here's another piece that creates the illusion of space in a bizarre way. From the side, it looks like nothing. From the corner, it looks like a perfectly formed human face. paintings. These are some of my favorites by Felice Varini. They are paintings that are used, the artist uses a projected geometric pattern onto a non-flat surface. That image is traced really carefully and then painted to make it look as if these things are floating in space. These spirals, for instance, are actually on the floor, the wall, and the ceiling, but if it looks like you're seeing floating three-dimensional circles spiraling in space.